Reference models are conceptual frameworks for understanding relationships. The purpose of the reference models are to guide vendors and developers so that digital communication products and software programs they create can interoperate and facilitate clear frameworks that describe the functions of a networking or telecommunication system. OSI, Open Systems Interconnection, is a reference model for how applications can communicate over a network. A reference model is a conceptual framework for understanding relationships. The purpose of the OSI reference model is to guide vendors and developers so that the digital communication products and software programs they create will interoperate and to facilitate clear comparisons among communications tools. Most vendors involved in the telecommunications make an attempt to describe their products and services in relation to the OSI model. And although useful for guiding discussion and evaluation, OSI is rarely actually implemented, as few network products or standard tools keep all related functions together in well-defined layers as related to the model. Developed by representatives of major computer and telecommunication companies beginning in 1983, OSI was originally intended to be a detailed specification of actual interfaces. Instead, the committee decided to establish a common reference model for which others could then develop detailed interfaces, which in turn could become standards. OSI was officially adopted as the international standard by the International Organization of Standards, ISO. So what about the OSI layers? The main concept of OSI is that the process of communication between two endpoints in a telecommunication network can be divided into 7 distinct groups of related functions, or layers. Each communicating user or program is at a computer that can provide those 7 layers of function. So, in a given message between users, there will be a flow of data down through the layers in the source computer, across the network, and then up through the layers in the receiving computer. The 7 layers of function are provided by a combination of applications, operating systems, network card device drivers, and networking hardware that enable a system to put a signal on a network cable or out over Wi-Fi or any other wireless protocol. The 7 open systems interconnection layers are: Layer 7, the application layer. This is a layer at which communication partners are identified. Is there someone to talk to? Network capacity is assessed. Will the network let me talk to them right now? And it creates a thing to send or opens the thing received. Please note that this layer is not the application itself. It is the set of services an application should be able to make use of directly, although some applications may perform application layer functions. Layer 6, the presentation layer. This layer is usually part of an operating system and converts incoming and outgoing data from one presentation format to another. For example, from clear text to encrypted text at one end and back to clear text at the other. Layer 5, the session layer. This layer sets up, coordinates, and terminates conversations. Services include authentication and reconnection after an interruption. On the Internet, Transmission Control Protocol, TCP, and User Datagram Protocol, UDP, provide these services for most applications. Layer 4, the transport layer. This layer manages packetization of data, then the delivery of the packets, including checking for errors in the data once it arrives. On the Internet, TCP and UDP provide these services for most applications as well. Layer 3, the network layer. This layer handles the addressing and routing of the data, sending it in the right direction to the right destination on outgoing transmissions, and receiving incoming transmissions at the packet level. IP is the network layer for the Internet. Layer 2, the data link layer. This layer sets up links across the physical network, putting packets into network frames. This layer has 2 sublayers, the logical link control layer and the Media Access Control Layer. Ethernet is the main data link layer in use. Layer 1, the physical layer. This layer conveys the bit stream through the network at the electrical, optical, or radio level. It provides the hardware means of sending and receiving data on a carrier network. Let's see some of the most famous protocols of the layers. For ease of use, it's better to talk about physical layer and data link layer together. Here we have some protocols in data link layer and some physical media and connection methodologies in physical layer. Ethernet and 802.11 wireless LAN are the most known protocols of the data link layer. Ethernet is the name of the most commonly used network protocol that controls how data is transmitted over a LAN, which is a local area network. You need to have network interface cards in the devices that you want to connect to the network. A wireless local area network, WLAN, is a wireless computer network protocol that links two or more devices using wireless communication within a limited area such as a home, school, computer laboratory, or office building. This gives users the ability to move around with a local coverage area and yet still be connected to the network. Most modern WLANs are based on IEEE 802.11 standards and are marketed under the Wi-Fi brand name. IP, Internet Protocol, is responsible for addressing hosts, encapsulating data into transferred packets, and routing packets from a source host to a destination host across one or more IP networks. The best-known transport protocol is the Transmission Control Protocol, or TCP. It's used for connection-oriented transmissions, whereas the connectionless User Datagram Protocol, UDP, is used for simpler messaging transmissions. We're going to talk more in depth about these protocols in the next lecture. Again, for ease of use, the last three layers, session layer, presentation layer, and application layer, are thought of together as the application layer. Let me put another parenthesis here. We're talking about the OSI reference model here. In addition, there is another reference model called TCP/IP reference model. And instead of OSI model's last three layers, there is only a single application layer in the TCP/IP reference model. Just keep that in the back of your mind. And back to our subject. The application layer protocols are classified according to the protocol they are using in the transport layer. And these protocols interact with the end user via applications. Therefore, they are the most known protocols by just about everybody. Some of the most well-known TCP-based application layer protocols are HTTP, Hypertext Transfer Protocol, simply a communications protocol used to send and receive web pages and files on the Internet. Telnet is one of the simplest ways to exchange data between two computers. It allows two computers anywhere on a computer network, including the worldwide Internet, to exchange text and, other data in real time. FTP, File Transfer Protocol, is a communication protocol for the rapid, simple transmission of files across a network. SMTP, Simple Mail Transfer Protocol, is used to send and relay an email message between email servers. Note that it is not used to retrieve email messages from a server. Instead, either IMAP or POP is used to retrieve email messages. DNS, the Domain Name System, is a system used to convert a computer's host name into an IP address on the Internet. For example, if a computer needs to communicate with a web server, nhs.uk, your computer needs the IP address of the web server, nhs.uk. It is the job of the DNS to convert the host name to the IP address of the web server. The DNS uses both the UDP and TCP. SNMP, Simple Network Management Protocol, is used in network management systems to monitor status of devices and also spot problems. So let's see what happens to a packet inside the network traffic. Please note, the data unit transferred between two endpoints has different names in each layer. In layers 5, 6, and 7, application layers, it's called data. In layer 4, transport layer, it's called segment for TCP and datagram for UDP. In layer 3, the network layer, it's called packet. In layer 2, the data link layer, the data unit is called frame. Now, I usually use packet for the transferred data unit in each layer to make it less complicated for you. Make sense? Before looking at the road trip of a DNS query in detail, let's look at the relationship between the OSI layers and computer systems. The packets in Layer 1 and Layer 2 are managed by network interfaces of your device, for example, by your Ethernet card. And the packets from 3 to 7 are managed by the processing unit. In software detail, the Layer 3 and Layer 4 packets are managed by the operating system of your devices. And the packets of Layer 5 to 7 are managed by the related application or service, for example, a web browser. When you write a URL in the address bar of your browser and hit Enter, the first thing it sends is a DNS query. A DNS query is the process of a computer or networking device making an inquiry to get an IP address for a DNS name such as mail.yahoo.com. The client computer will send a DNS query to one of their Internet Service Provider's DNS servers. The DNS server looks in its DNS database to tell whether it can answer the query authoritatively. If the DNS server can answer authoritatively, the DNS server answers the query and the DNS query process is complete. So let's see the road trip of a DNS query from your computer to a DNS server. When data is transmitted by the source toward a specific destination, it passes through the application, presentation, and session layers, and the protocol data unit arrives at the transport layer, Layer 4. Layers 5, 6, and 7 are displayed as a single layer to simplify the presentation. At this layer, a 20-byte data header is placed in front of the data. A DNS query can also use TCP, but let's assume that it uses UDP at this time. The data and the Layer 4 header, here it's UDP header, which together form a segment or datagram, is passed down to Layer 3, the network layer. The network layer places its Layer 3 header, here the IP header, in front of the received segment, and this group becomes a packet. The Layer 3 header contains important fields such as the logical address, the IP address, of both the source and the destination device. The newly formed packet is then passed down to Layer 2. The data link layer creates a new data unit called a frame by adding the Layer 2 frame header, which is the Ethernet header here. Like Layer 3, an addressing structure is also applied in the Layer 2 header. That is, the MAC address. The frame is then passed down to the physical layer, which converts the information into 0 and 1 bits that are sent over the physical media using electrical signals, on a copper link, for instance. Finally, the data is sent over the wire using a wide variety of methods such as Ethernet or token ring. The headers are a specific form of control information that allows the data to go through the network properly. Thus, the data at each layer is encapsulated in the information appropriate for the specific layer, including addressing and error checking. The overall size of the information increases as the data travels through the lower layers from Layer 4 to Layer 1. The destination device, which is the DNS server here, receives the data, and this additional information is analyzed and then is removed as the data passes through the higher layers up to the application layer, where the data is decapsulated. The TCP/IP model is a model with 4 layers, which is for both modeling current Internet architecture, as well as providing a set of rules that govern all forms of transmission over a network. DARPA, an agency of the United States Department of Defense, created it in the 1970s. This model was being made at the same time the OSI model was created. The TCP/IP model is not the same as the OSI model, however. It was influenced by the model, which is why many of the names of the different layers are the same. So we can simply say that the TCP/IP reference model represents reality in the real world, whereas the OSI reference model represents an ideal. Okay? So these are the main differences of the TCP/IP reference model. The three top layers in the OSI model, that is the application layer, the presentation layer, and the session layer, are not distinguished separately in the TCP/IP model, which only has an application layer above the transport layer. TCP corresponds to OSI layer 4, the transport layer. IP corresponds to a subset of OSI layer 3, the network layer. TCP/IP makes no prescriptions as to the link layers below IP, while OSI specifies 2 layers. The physical address, commonly the MAC address, which is located in a special field in the data link layer header, changes as the packet passes from one device to another. For example, from the source PC to a switch, to a router, to another switch, and then finally to the destination PC. However, the original IP source and destination addresses do not change when transiting the network because the packet is stripped of its layer 3 header only when it goes beyond a router. When it stays within the same LAN, it only passes through switches, which decapsulate it at the layer 2 header containing the MAC address. So as a result, the header changes as the packet is re-encapsulated, as does the MAC address fields.